Today we're going to do a quick radical review before we start chapter 8 and a couple of quick things. This whole term is called a radical, and the square root sign or the root sign is your radical symbol, and then whatever is underneath the radical symbol is just called your radicand. Now, most of what we will be dealing with this year are going to be square roots, and we don't write that understood index of 2. Now, I want you all to simplify these 3 square roots right here, pause the video, and come back to check your answer. So hopefully you recognize that the first 2 were perfect squares. The square root of 25 is 5. The square root of 81 is 9. The last one is a little bit interesting, and the answer to that one simplified is going to be 2 square root of 6, and we're going to talk about that a little bit more here. So anytime you have something underneath the radical that's not a perfect square, you want to break it up to be able to pull your perfect square out. So here, if you have the square root of a times b, you can split that up into the square root of a times the square root of b, and you can simplify if one of those is a perfect square. So if we take a look at the square root of 45, we know that the biggest perfect square that goes into that is 9. So we could rewrite this as the square root of 9 times 5, or we could write it as the square root of 9 times the square root of 5. And we all know that the square root of 9 is just 3, and so this would be 3 times the square root of 5. Now, I want you to try the next 2 and then come back and check your answer. So I'll give you a second to check your answers. One thing that I do want to note on this last one, if you didn't recognize that 36 was the biggest perfect square that would go into 72, and you just remembered 8 times 9 gave you 72, that's totally fine. Just make sure anything outside your radical you're going to multiply together ultimately to get 6 radical 2. Now, one thing I do want to point out here is that if you had something like the square root of, we'll just say a squared plus b squared, um, we cannot pull out the square root of a squared plus the square root of b squared. That is not good math right there. And the reason I'll show you that is if we had the square root of 13, right, we know that can't be simplified. Well, you could rewrite the square root of 13 as the square root of 4 plus 9, right? 4 plus 9 gives you 13. Well, this is the square root of 4 plus the square root of 9. We know the square root of 4 is 2. We know that the square root of 9 is 3, and that's going to equal 5. And 5 does not equal the square root of 13. So I just want to show you, be really careful here. The only time you can separate these radicals is if you're multiplying underneath the radical, not if you're adding or subtracting. Okay, so let's take a look at the last thing that we have here, which is talking about the quotient rule. Remember that you cannot have any radicals in the denominator when you have simplified a term. And one of the things that can help us here, if you have the square root of a over b, you can split it up into the square root of a over the square root of b. So some of these are going to be pretty simple, like in this first one. So if you have, you can split this up into the square root of 4 over the square root of 9, which is going to easily simplify since both of those are perfect squares. It'll simplify to 2/3. Now here, if we have the square root of 53 over the square root of 121, and hopefully you recognize that 121 is a perfect square of 11. Now, we can keep going here. Now, the square root of 53 cannot be simplified. I want you all to try the last 2 and then check back here. Now, I want you to check your answer for the third one. You do see that we did have to simplify our numerator there. And the last thing that I want to show you is on this last problem, I did simplify my x's first underneath the radical, which helped me to get an x squared that I could pull outside of my radical. And so then I have something simplified. Now, another thing that you may be asking yourself, remember that if we had something like 2 over the square root of 3, if we had gotten an answer to this point, we can't leave it like that, and we would have to rationalize our denominator here. And by rationalizing our denominator, what we're doing, in essence, we're going to multiply this by 1, which 1 is the square root of 3 over the square root of 3 to get rid of that denominator. The square root of 3 over the square root of 3 is just 1. I call that the power of 1. So we are writing this in an acceptable way. So this ends up being 2 square root of 3, 2 times square root of 3, and then the square root of 3 times the square root of 3 just gives you 3. So this would be an acceptable way to write that. You do not want to leave a radical in the denominator. Now the last thing that I want to remind you of is that when you are adding or subtracting numbers, be careful about combining like terms. If you had the square root of 5 plus 4 square root of 5 minus 3 square root of 5, you can add all of these coefficients. These are all like terms. The coefficient of this first term is just an understood 1. So you have 1 plus 4, which gives you 5, minus 3, which gives you 2 radical 5. Now, if you had something like 3 radical 5 plus 7, can you do anything to simplify that? No, you cannot combine those terms. Cannot combine because they're not like terms. Same thing if you had something like 3 square root of 5 plus 4 square root of 3. These are not like terms, so you cannot combine that. So just be on the lookout when you have radicals, when you're adding or subtracting for like terms.